What is traceline? Traceline is a function which takes two positions in 3D space and discovers if there is a collision in between them. It does this by drawing a virtual line from the source to the destination, and on each specific increment, it detects if a collision with another object has been detected. If we look at assaultcube here, I am looking at Timber so we can see his name in the lower left-hand corner. When the wall's in between us, the name disappears. So this is using a traceline function to detect that. There's many different ways to find this, and there are many different types of these functions used in every 3D game because collision detection is a hugely important part of 3D game programming. So how do you find it? Anytime you're asking yourself that question, you have to think logically like you were the game designer. How would I detect if my bullet was going to hit someone when I pull the trigger? Well, inside my shoot function, I would call traceline. How do we get that name in the lower left-hand corner to pop up? Well, again, we need to call traceline. So what you want to do is find things that you know and trace back to the things you don't know. So I'm going to show you two ways to find it in assaultcube. If you haven't watched it already, I did a triggerbot tutorial in assaultcube which teaches you all about it, and we do touch on traceline just a little bit, and that's how you get the name in the lower left hand corner. So for this video, we're going to try the different way. So we are going to start with our weapon ammo because we want to find our shoot function. So to find the shoot function, we're going to start with our current weapon ammo, and we're going to find out what writes to its address. When we shoot the gun, we get the decrement ammo instruction. So after we shoot our gun, we decrease our ammo. So that's probably in or after the gun shoot function. So we are going to grab that address and we're going to go straight into IDA Pro. Paste that in and F5 it. I always F5 first. Get a top-down, high-level view of what you're looking at so you can identify important things quickly, and then later when you need to really dig down into it, you can look at the assembly. So let's just say this is the gun shoot function, which I'm pretty sure it is. We see it is a this call function, so that means it's a member function, and that this is probably a vtable function. So let's just see if we can identify any of these things here. So 50F4F4, rename, we know this is the local player pointer. See what else we can find. We see down here, this is our decrement ammo function. And how do we know that? Well, we're doing the decrement instruction, and it's V2, and it's indexing into the fifth element of the V2 array. This is just how it's accessing that variable. It's not technically an array. What is V2? If we go up here, V2 is right here, and V2 gets its value from this pointer. So V2, we're just going to rename that to this 2. It's just a copy of this. So when we're down here and we're looking at this 2 index 5, it's indexing into the fifth 4-byte variable in this object, which we know is a weapon object. In the previous videos, we reversed engineered the weapon class. So when we're talking about the fifth 4-byte element, what are we talking about? Let's shrink these guys down. And we have 0, 1, 2, 3, 4, and 5. So the fifth variable in that array is mag ammo. So that's the ammo in that we're decreasing, right? So we figured out what that means. Now, before this, we see a couple function calls. We see this one, and then we see these two, which are other vtable functions being called using a function pointer. So this 2 represents our vtable. 20 divided by 4-byte addresses is 5, and 16 divided by 4 is 4. So this is calling the 4th and the 5th vtables. So let's go over to Class Informer, the plugin, and let's search for gun. And we see all the guns. We can also search for weapon, and they all happen to be in the same place. We have a submachine gun right now, so let's look at that one. And when we look right here, we see our shoot function. We see the sniper rifle calls a shoot function. They all call the same shoot function, okay? There might be 1 or 2 different ones. They all basically call that. So what are the 4th and 5th vtable functions that's calling? So we want to look at the 4th and 5th vtable functions. So 0, 1, 2, 3, 4, and 5. So these are the 2 we want to look at. Let's look at 463810. F5 it and look at the decompilation. It is another this call function. This pointer is the weapon object, and then it takes 3 variables. If we look at them, A2 plus 0, A2 plus 4, A2 plus 8. So that looks like a vec3, right? So let's jump into this 4, 8, A3, 10, and let's look at this function. So let's go back again. The first argument is v7, and then after that we have 1, 2, 3, 1, 2, 3, 1, 2, 3. But it's two vec3s being passed in after one integer, which looks just like a pointer to a variable. The first argument that gets passed in is passed in an EAX, which is weird. So this is detected as a user call. So IDAPRO, when it doesn't understand the calling convention, it will say it's a user call. So we already know it's kind of funky. And we know that these float things, it's the source and destination operands probably for some sort of traceline function. I already think this is traceline, so let's just rename it. And we're going to find out why in a bit. You can always rename it later. Now, we know what these variables are. So let's do set item type. And we're going to leave that first argument alone, but we're going to delete 1, 2, 3, 1, 2, 3. We're going to delete all of those, and we're going to pass in a vec3 source and a vec3 destination. So that's what our real function is. Now, we can't declare that because we haven't defined a vector. So to define our own structures, let's go to View, Windows, Sub-Windows, Local Types, and let's do right-click Insert and do struct vec3 float xyz. Now we can rename our trace line, set item type. I had copied that, so I can just paste that in. It's not letting me do it again. There we go. Okay, so now that is in there correctly. So let's click source and let's scroll down and see. You can see how it's now accessing the X and the Y, which is really awesome. It makes this much easier to read. Let's scroll down and see what else we can discover. Well, I see this loop here, and it's a for loop, and it's checking F0, F4, F8. That's our array that we're going through. So we know that is the entity list. Okay, ent list 50F4 500 is the number of ents. So we're only looping through an array of entities if a 9. So this is like a check if player collision, right? So let's do b check players, because if that's false, it doesn't even loop through them. And then inside here we see sub 488880 4603C0. So let's say this is a traceline function, right? It's doing a bunch of math and calculations and tracing these lines. So then it's checking if it's done any collision with any of these entities. So inside of this ent loop, it's calling these two subroutines. So are either of these some sort of traceline function? This looks like the distance formula. And if we look at this, it should be square root. So yeah, that is the square root. We can rename that. And if we, yeah, this is the distance formula. So we already know what this is. Distance. And we can actually set the item type, because we know it's just two vectors, right? It's vec3 source, vec3 destination. So cool, that's distance formula. Where were we? So yeah, we call the distance. So this is going to be dist. And this is going to be a copy of dist. And then what is this? Doesn't matter. Down here we have another function that gets called. Let's take a look at this. So as I said before, when you're talking about traceline and collision detection, there are going to be like 15 different functions that do this in every game probably, okay? The one we want is the one that checks the entities, and that's the one we're just looking at. So we don't need to call this function. We need to call the function we were just looking at, because this is the one that tells us if it's collided with an enemy. We've already figured that out, so I'm pretty sure already this is traceline. In fact, I know it is because I've recorded this video like 4 times now. So let's try to find out what these other arguments are. What's A10? Scroll down, find A10. And we really only see it once or twice, and it's just checking if it's set or not. So it's some sort of bool. So I'm just going to put that in there. All right, we don't know what it is. It doesn't matter. We just know it's a bool, so it kind of gives us some context here. So how important is this bool? All it does is set this one byte to 1, and then down here it gets set to 0. So depending if this bool is set, this bool is just bool number 2. Some bool 2. And then down here it gets set to 1 again. These are like, yeah, it's two parts of an if-else statement, okay? But what you'll notice is there's no function calls in here that take a source and destination, so none of these are traceline functions. The only time we see, we have the distance function, and then this function takes source and destination x. Let's take a look at that. Could be some sort of intersect function, destination, collision detection, not sure. 46050. Not sure. Some of these functions, what they do is not obvious. This one, it's pretty obvious because we see this loop right here. The other ones are just doing a lot of float math. So in order to call this function, we need to know the calling convention and the arguments. We know this one's not really important, so we could pass in a 0 or 1 and just see what happens. B-check players, we know we want to send in true, not false. And then we have source destination, and then what's passed in EAX? A1, a copy is made and it's put into V9. A1 is just X plus V6 and V7. So you can see source X, source Y, source Z, and then it's V6, V7, right? All it's doing is setting A1 to these three things. Why is it setting these things and not making, like, it's accessing them via a pointer, getting the value of, and it's setting it? So this is a pointer to some sort of structure. It could be a vec3 or something like that. So let's see if we can discover that. Let's see if A1 has any other variables by seeing if it gets... We have A1 plus 0 plus 4 plus 8, so that's our vec3. Now this is going plus 12, so now there's a fourth variable. So this is not a vec3. Could it be a vec4? Yeah, certainly could be. But I don't see how you would need the W variable from a vec4 when you're just doing this type of math for collision. You know, we're not doing matrix math here. Again, we just have this large distance, large float distance 2. Because when it's looping through this, it may collide with 3 or 4 things, but it wants to find what does it collide with first. Because if you shoot, your bullet's gonna hit the first person, not the people behind them, right? So that's why it uses that. That this variable A1, this is like a pointer or a reference to some structure. So this is like the return value kind of thing, right? It's a void. But once this function is called, it doesn't return anything because it's void, but it does modify this variable that's passed as like a reference. Weird. It's still weird that it's passed in EAX. Now let's find what A8 might be. So if V29 does not equal A8, what is V29? V29 gets this address from ent list plus 1. So this is just current ent. That's all that is. Oh, I know what A8. Remember we were talking about when you call traceline, you want to make sure that you're not colliding with yourself because your origin position is inside your body. So the first thing it's going to collide with on its path is going to be yourself. So A8 is like a trace owner or something like that. Trace owner. Yeah, that makes sense. So this is crazy, right? So obviously I've been doing this for a couple years, but if you have IDA's decompilation, you can discover what a function's doing as long as you have a background of reversing that game. Because we were able to figure out we knew what the ent list was, we knew what number of entities was, we know about large floats being used as comparisons, and once you start filling out that information, it's just really obvious what this function's doing. And look, we've already reversed this. When you first looked at this with all those individual floats, it looked like it was insane. What I'm trying to say is, once you have the experience, this stuff is really quite easy. Another thing I want to explain, if we're doing a trace line between me and the nut, right? It's basically doing a translation. Basically, if we're doing trace line between me and him, first thing we're going to do is we're going to calc angle to get our angles to him. And then we're going to do a translation across our current view axes towards him. So the traceline function is basically going to go forward 1, check collision, forward 1, check collision, forward 1, check collision, and it's going to keep doing that until you're right up against on him, and now we're intersecting. So when it calls it now, it's going to detect the collision. So just to explain, you can do that with matrix math, but you can also do it just with regular trigonometry. This is a function I made called move in camera direction, and it just uses cosine and sine to do that. And if you were to you can use this as like a fly hack, and you'll actually fly in that direction. The nut also shared a way of doing it using angle vectors. So last thing is we need to find out what is with this EAX, because that's bizarre. So let's do jump to cross-reference. Let's do, yeah, jump to cross-references, and let's find a function that calls it. I think we were looking at this function before, right? 4638. So let's call this traceline wrapper. So remember, traceline is not a member function, but this one is a member function in our weapon class. I think that's right. We have a shoot function, traceline wrapper. So this is really what gets called. We also have this 462020, and let's go in here, F5, and see what we got. No function calls. Oh, here's one. 2 function calls. So, you know, this is just like another weird like intersect function, right? Intersecty func. We don't really know what that is. So now what we should do is let's look at it from a different angle. Right here we got the nut. Let's try to find it using a different base point. Let's search for the nut. Right? And then let's look at this guy, xdarian x. Look at this guy, the nut, xdarian x. We see that this second variable changes. So let's add that to the table. That's the current entity in Crosshair. If you did the previous tutorial, you would know all about it. So let's find out what writes to this address again. And then let's look away and then look at these guys. Okay, so, oh my god, I stopped it on 1337. Is that even this is a sign from God. Holy shit, guys. I'm officially leet. Unbelievable. Stunning. Absolutely amazing. Proof from God himself. I am the chosen one. Okay, anyways, show this, that is insane though. Show disassembler, yes, and so this is, let's grab that address, and let's go to IDA, and jump to it, and it's decompiling it. That took a while, actually. It must be a big-ass function. Yes, it is. So yeah, we saw this in the last video. This is the whole HUD drawing. We just call us draw HUD. And down here, oh, lost my spot now. Right, so here it is. It's if v15, then we are going to loop through this. Our incrementer is v17. It's a char pointer. If we look at this in hex 225, that is the offset to the player's name in the entity object. So it's getting each character in the thing because it's making a copy of its name or whatever, and then it's printing it to the screen. So v15 is the get crosshair ent function. I cannot type. This is so sad. So let's go in there and check this out. Get crosshair ent 509b74. This is our local player. Again, all the context you have from reversing a game is going to be helpful. So sometimes it's helpful just to reverse tons of crap. Oh, this is actually local player 2. There's 2 pointers to it. And then we got this, 460670. So to get the crosshair on entity, it has to call traceline. So this is another wraparound traceline, guaranteed, right? Pop this open and scroll down. We see our square root. We see 4603C0. Hey, weren't we just looking at this? So this is get crosshair ent2, basically. Back and look at the previous one. It's an intersect function. So offset +4 of your local player object is your source coordinates. This is God knows what. This is, remember, you always pass in the tracer owner. So yeah, this is like traceline 2 or some sort of other intersect function. And then we're passing in v2 and 0. This is a user call. Keep looking, sub 4603C0. This is a user call again. So again, this is some kind of weird intersecty func too. So the point of showing you this get crosshair ent function was to show you how you can trace backwards from this function to the traceline function. So if we right click this and to jump to cross references, this is the only place that it's called. So let's go into this function, and we know this is some sort of intersect traceline function. So again, we want to see what other functions call these functions that might be similar. And we could check through all of those and try to see what they are, but I don't think that's it. If we go into this one and do find out what cross references here, this intersect function is called by traceline 2 and traceline 1. So now we've traced from the get crosshair ent function back to our correct traceline function. The last thing we need to find out is what is up with EAX. So we're going to jump to cross-references, go to Traceline Wrapper, and now we need to view this in assembly. So let's grab that, and let's go to I to view here, and jump to it, and we need to find the call. So here's the call Traceline, and you can see it calls LEA, load effective address of this thing, and puts it into EAX. So we're pushing our arguments in reverse order, right? Push 0, push 1, those are our two bools. Pushing EAX, which is argument 8, loading effective address into EAX, and then calling Traceline. So this isn't a function that uses a regular calling convention. It has been mangled by the compiler as part of an optimization. So if you want to call it yourself, you need to use inline assembly or some sort of wrapper that does that for you. And so we've already done that. So this is my function for my own class I've created called isVisible. And that's the address of the Traceline function. The variable which it was passed by reference that stores like the result of the Traceline function is called traceResults, which is just a structure that says who it collided with. And traceResult.collided, we set it to false. We're going to trace from our head to the enemy's head because my aimbot aims at the head. And then we're going to push the arguments onto the stack. Bskip tags, check players. This is the unknown bool that we couldn't figure out. Check players, local player, and then our source and destination. And then we want to do just like the assembly does, load effective address, the address of trace result, and then we call Traceline. Once that's done, we fix up the stack and we check if traceResult.collided is true or not. If you want to see how this all works in a completed project, we have several AssaultCube aimbots that all use this function. We're all basically doing it the same. So there you have it. 2 ways to find Traceline in AssaultCube. I really hope you enjoyed this video. Again, guidedhacking.com/donate, patreon.com/guidedhacking. Please support us so that we can continue to make videos, and peace out.